Is the tapestry of existence woven from threads of pure mathematics, a grand computation unfolding in a cosmic machine beyond our wildest imaginings? The notion that our perceived reality, the solidity of the ground beneath our feet, the intricate dance of galaxies, the very thoughts that flicker within our minds, might be an elaborate simulation, is a concept that has crawled from the speculative fringes into the arena of serious, albeit eyebrow-raising, scientific and philosophical debate. Imagine, for a moment, a civilization far more advanced than our own, possessing computational power that dwarfs our most ambitious supercomputers. Could such a civilization, perhaps as a form of ancestral simulation, an experiment, or even a sophisticated entertainment, construct a universe so detailed, so internally consistent, that its inhabitants would never suspect its artificial nature? The idea is not merely a modern flight of fancy. It echoes ancient philosophical ponderings about the nature of reality, from Plato's allegory of the cave, where prisoners mistake shadows for truth, to the dream arguments of Zhuangzi, who wondered if he was a man dreaming he was a butterfly, or a butterfly dreaming he was a man. What lends this seemingly outlandish concept a sliver of plausibility in the 21st century are subtle whispers from the frontiers of science. Consider the strange, almost digital behavior of the universe at its most fundamental level. Quantum mechanics, the bedrock of our understanding of the subatomic world, describes a reality that is probabilistic rather than deterministic until measured. Particles exist in a superposition of states, like a character in a video game whose attributes are not rendered until an observer interacts with them. Could this be a sign of computational efficiency, a universe that only calculates what needs to be calculated, when it needs to be observed? Furthermore, the very laws of physics themselves seem to possess an uncanny mathematical elegance. Eugene Wigner, a Nobel laureate in physics, spoke of the unreasonable effectiveness of mathematics in the natural sciences, questioning why the abstract constructs of mathematicians should so perfectly describe the workings of the cosmos. Is this elegance a fundamental truth of an independent reality, or is it the underlying code of a simulated world where mathematics is the language of its creation? The universe, in its grandest and smallest scales, seems to adhere to rules, to limits, the speed of light, the Planck length. Are these inherent properties, or are they the processing constraints of an unfathomably vast computational system? The questions are as profound as they are unsettling, inviting us to look at the world around us not just as a given, but as a potential masterpiece of digital artistry. The suspicion that reality might be less real than we presume gains an intriguing edge when we consider the very fabric of space-time. Physicists have long grappled with the concept of a Planck length and Planck time, theorized to be the smallest possible units of space and time, respectively. Below these scales, our current understanding of physics breaks down. This notion of a fundamental discreteness, a sort of cosmic pixelation, resonates uncannily with the structure of digital information. If our universe were a simulation, it would necessarily have a finite resolution, a smallest possible unit, much like the pixels on a screen define the limits of a digital image. Could the Planck scale be the ultimate resolution of the simulation we inhabit? Further fuel for this speculative fire comes from the realm of information theory. The Bekenstein bound, for example, posits a maximum limit to the amount of information that can be contained within a finite region of space with a finite amount of energy. This suggests that, at a fundamental level, the universe might operate on principles akin to information processing. Physical systems, from black holes to elementary particles, can be described in terms of their information content. The holographic principle, an even more radical idea stemming from black hole thermodynamics, proposes that the information content of a volume of space can actually be encoded on its boundary, like a three-dimensional image projected from a two-dimensional surface. If the universe itself can be described as information, then the step to it being processed information, a simulation, becomes less of a chasm to leap. Philosopher Nick Bostrom, in his seminal paper, presented a trilemma that further stirs the pot. He argues that at least one of the following propositions must be true. 1. civilizations almost invariably go extinct before reaching a stage of technological maturity capable of creating high-fidelity ancestor simulations. 2. Technologically mature civilizations are almost invariably uninterested in running such simulations. Or 3. We are almost certainly living in a computer simulation. Given the exponential growth in computing power we have witnessed even in our own relatively brief technological history, and assuming that this trend could continue for other civilizations over cosmic timescales, the capacity to simulate universes becomes a distinct possibility if such simulations are feasible, and if there's even a mild interest in running them, for research, for art, for reasons we cannot yet fathom, then the sheer number of simulated realities could vastly outnumber the single base reality. This doesn't mean we can spot lines of code scrolling across the sky or find a cosmic Control-Alt-Delete switch. If the simulation is sophisticated enough, its internal physics would appear perfectly consistent and natural to its inhabitants. The programmers would likely not leave obvious breadcrumbs. Yet the thought persists. Are the laws of nature simply the algorithms of this grand program? Are physical constants the finely tuned parameters? The consistency we observe, the mathematical underpinnings, could be interpreted not just as inherent truths of an independent existence, but as the elegant architecture of a meticulously crafted digital world. The search for glitches in the matrix, while often a trope of fiction, takes on a more nuanced meaning here. Perhaps subtle anomalies in physical data or unexpected cosmological observations could be faint whispers from the operating system. If the world around us is indeed a sophisticated rendering, what then of ourselves, the inhabitants? Are our consciousnesses, our deepest feelings of love, sorrow, and ambition, merely complex algorithms, emergent properties of the simulation's code? This is where the philosophical ground trembles most violently. The problem of consciousness is already a profound mystery. Transplanting it into a simulated framework adds layers of bewildering complexity. If awareness can arise within a sufficiently complex computational system, then a simulated being could, in principle, be as genuinely conscious as its creator. The simulated joy or pain would be no less real to the one experiencing it. This raises an ethical labyrinth for any potential simulators. What responsibilities do they bear towards the sentient beings they may have brought into artificial existence? The very notion of free will also undergoes a disquieting transformation. If our actions are determined by the underlying rules and initial conditions of a program, is there any room for genuine choice? Or are we simply tracing pre-calculated paths, our struggles and triumphs, merely the unfolding of an intricate script? Some might argue that even within a deterministic system, the complexity could be so immense that choice feels authentic, and for all practical purposes, Noosh is authentic from our perspective within the simulation. Perhaps the simulation is not a rigid script, but more akin to a massively multiplayer online role-playing game, where players have agency within defined rule sets, their interactions creating unscripted emergent narratives. One of the critical challenges leveled against such a grand hypothesis is its potential unfalsifiability. How could one ever devise an experiment to definitively prove or disprove that we are living inside a simulation? If the simulation is perfect, any test we conduct would itself be part of the simulation, its results predetermined or managed by the system. However, some theorists propose potential avenues for investigation. For instance, searching for inherent computational shortcuts or resource limitations reflected in physical laws, or looking for evidence of the underlying grid, the discrete nature of spacetime, at extremely high energies beyond what our current particle accelerators can achieve. Could there be a refresh rate to reality or telltale rounding errors in physical constants if they are stored with finite precision? The rabbit hole deepens with the chilling, or perhaps exhilarating, prospect of nested simulations. If our civilization could one day create its own ancestor simulations, who is to say that our simulators are not themselves a simulation, created by an even more advanced civilization? This leads to a potentially infinite regress, a tower of realities stacked one upon the other. In such a scenario, the base reality, the ultimate non-simulated universe, becomes an almost mythical concept. We could be simulations within simulations, digital echoes reverberating down a long corridor of computational creation. The sheer scale of such a possibility is mind-boggling, reducing our cosmic significance, yet simultaneously imbuing our existence with a strange, almost mystical quality. The quest for understanding our place in the cosmos takes on a new, digital dimension, where the search for fundamental laws might also be a search for the operating system's source code. Ultimately, whether the universe is a grand cosmic simulation or a self-existing material reality may remain an enigma, a question teetering on the very edge of knowability. The hypothesis, while provocative and rich with intellectual intrigue, currently floats in a realm where empirical evidence is scant, and direct proof seems an almost insurmountable hurdle. Yet its true value might not lie in its eventual verification or refutation, but in the profound questions it forces us to confront about the nature of existence, consciousness, and the limits of our understanding. To entertain the thought that our reality is constructed is to engage in a powerful act of intellectual humility. It challenges our innate assumption that what we perceive is the totality of what is. It compels us to question the very foundations of our knowledge and to consider that the laws of nature might be more akin to the rules of a game than immutable truths. This perspective can foster a deeper sense of wonder, transforming the mundane into the mysterious, every observation potentially a clue to a larger, hidden architecture. If the universe is a simulation, then every discovery, every scientific breakthrough, is not just an uncovering of pre-existing facts, but perhaps a glimpse into the sophistication of its design or the intent of its designers. Conversely, even if the simulation hypothesis turns out to be a fascinating but ultimately incorrect detour, the journey of its consideration can be illuminating. It pushes the boundaries of physics, computer science, and philosophy, forcing these disciplines to interact in novel ways. The computational thinking applied to cosmology, the information-theoretic lens on physical laws, and the philosophical rigor applied to digital existence. These interdisciplinary explorations enrich our intellectual landscape regardless of the ultimate truth. Perhaps the most significant impact of pondering such a reality is the way it reframes our own creative endeavors. As we ourselves stand on the cusp of creating increasingly complex virtual worlds and artificial intelligences, the simulation argument holds up a mirror. It makes us consider the responsibilities inherent in creation, the nature of artificial sentience, and the potential for our own technological descendants to one day ask the same questions about us that we ask about our potential simulators. In the end, the feeling of being alive, of experiencing the universe, whether real or simulated, is undeniably present. The beauty of a sunset, the complexity of human emotion, the thrill of discovery. These experiences retain their power. The simulation hypothesis doesn't necessarily strip away meaning. Instead, it might add a layer of sublime, almost surreal, context. We may be characters in a story far grander and stranger than we can currently comprehend. The call, then, is not to despair at our potential artificiality, but to embrace the mystery with open minds, to continue our relentless quest for knowledge, and to live vividly within the reality we are given, whatever its ultimate nature may be. The search for answers continues, and perhaps the very act of questioning is what truly defines our place within this intricate, possibly digital, cosmic play.